Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So now for today, we'll be focusing on the revision that is of your paper 1 examination and your paper 2 examination as well. Okay, so now when it comes to the mark allocation for paper 1, we have your section A, which consists of 10 multiple choice questions and has a total of your 20 marks. And then we'll also have either 8 matching items or one-word items, which has a total of 8 marks there. Then your section B will consist of your structured or long questions, which consists of 122 marks. And your paper 1 will be a total of 150 marks. That is with a duration of 3 hours there. Okay. And then now when it comes to the mark allocation for your paper 2, you will now have your section A, which consists of 5 multiple choice questions. And those multiple choice questions will consist of 10 marks. Then you'll have your section B, which consists of structured or long questions, and they will have a total of 65 marks there. Now the total for paper 2 will be 75 marks and with a duration there of 1 hour, 30 minutes. Now this is what you should expect with the layout of your paper 1. So you can then expect the following. Question 1, we know that is your multiple choice questions. Then after we'll have forces and Newton's laws, momentum and impulse, work, energy and power, elasticity, viscosity, hydraulics, light, your electromagnetic radiation, your electric circuits or electricity, as well as your electromagnetism there. So now this is what we have in relation to paper 2. So we know that with electrochemistry, we have what? We have the galvanic cell as well as the electrolytic cell. So now in preparation for the examination, you should make sure that you know how to define the following with either your galvanic cell or your electrolytic cell. So you should know how to define your oxidation, your reduction, your oxidizing agent, reducing agent, electrolysis, the anode, the cathode, the electrolytic cell, the galvanic cell, as well as the electrolyte. So then from the definitions, we are saying that how many marks are we therefore expecting, depending on how many definitions you are given, which can be a minimum of 1 or 2 definitions from either the galvanic cell or the electrolytic cell. We are saying that each definition is about 2 marks then. Then again, when it comes to this chapter, you should make sure that you know the following, the components of the cells. So with that, we are saying that you should know how to identify the components of the galvanic cell as well as the components of the electrolytic cell. Now with the galvanic cell, then you should know the function of the Saw bridge. Remember, we've got 3 functions in terms of the Saw bridge. So make sure that you know the functions of the Saw bridge. Then, very important, we cannot do electrochemistry without knowing or writing the half reactions. So make sure that you know how to write the half reactions. And that is for both the galvanic cell as well as for the electrolytic cell. Then you have an option of what? You have an option of table 4A or table 4B. So whichever one that you use, you must make sure that you know how to use it correctly. And then for the galvanic cell, then you need to know you need to know the cell notation. So we know that cell notation, how do we write it? We write it from the left to the right. The left, it's going to be what? So the left, we are going to have the A, B, C, whereby from the left we have the anode, which is the letter A. B will be the Saw bridge, and then C will be the cathode there. Then next we have the polarity. So when it comes to polarity, we are saying that you should know the electrodes to say for a galvanic cell, what are the electrodes? Is the anode the positive one, or is the cathode the positive or the negative one? As well as for the electrolytic cell, you should know the polarity. And then you should know the movement of the electrons to say, are the electrons going to be moving from the anode to the cathode, or the electrons are going to be moving from the cathode to the anode? So very, very important. And we are therefore saying that if you are at least able to know all of that we have there by number 2, we are saying that at least you will be able to get the very minimum, which is about 3 marks there. Number 3, this one relates more with the electrolytic cell. You should know how to identify the decomposition of copper 2 chloride, and then you should also know electroplating by another metal. So with the electrolytic cell, that means that you should now know that, okay, if I have the electrolytic cell, which anode will be the negative, which electrode will be the negative one, or which electrode will be the positive one. And then from there, that is when you're going to talk about what breaking down of the electrolyte. That was our number 1. And then number 2 was what? Number 2 would then be migration, to say, okay, once I have the electrolyte, where are my ions going to be migrating? And then from there, number 3, then we can talk about what? The redox. So with this 2, so by number 3 there, with this 2, we are saying that you must be able to do what? You must be able to write the half reactions, as well as be able to explain the observations, to say that, okay, when it comes to the anode or the cathode, you are going to observe what? You are going to observe a decrease or an increase in mass. What kind of a product are you going to form? If ever there's a production of chlorine, then you need to know how to say all of that. So with that, then we are saying that you should at least be able to get a minimum of what? A minimum of your 3 marks there. And then with number 4, then it says the calculation and what? Calculation and substitution. So with that, you are going to use what? You are going to use your formula sheet, and then you will see that from the formula sheet, then you are able to get the 3 formulas, okay? So you can then be able to use any of the 3 formulas because they all represent the same thing. So it's E cell is equals to the cathode. It's either the cathode, we know that is where reduction will be taking place. And then we also know that it is the oxidizing agent. And then with this one, it says E anode, that is where oxidation is taking place, and that is where we have the reducing agent. So what we are saying there is that you are expected to know how to calculate the what? You are expected to know how to calculate the E cell. But remember, for you to calculate the E cell, it means that you must be able to use table 4b correctly. And when you use the table 4b, what is it that you are going to do? It means that you will first need to identify which one is the anode, and then you will need to identify which one is the cathode. But if you use table 4b, you will know that whatever that is at the top, it represents the what? It represents the anode, and then whatever that is at the bottom, so according to our ABC, whatever that will be at the bottom of the table, it's going to represent the what? The cathode. So once you are able to identify, then what are we saying? You can then be able to substitute the values there. So you can then substitute the value of the cathode as well as substitute the value of the anode. So then what does it mean? It means that you'll get 1 mark for the formula there, 1 mark for the substitution, and then of course it's going to be what? It's going to be 1 mark for the final answer, and then the final answer with the what? With the correct unit there. Okay, so when it comes to your galvanic and your electrolytic cell, you must make sure that you are able to know the following that we have here on the table there. So now learners, if you have any questions, you can send your questions to the following WhatsApp number. 079-578-2908. If you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908 there. Okay, so now let's have a look at the following question here. It says the cell in the diagram below consisting of cobalt electrode, okay, and connected to the silver electrode is set up under standard conditions, okay. So now looking at the cell, what is it that we can see? We can see the CO, which is the cobalt, CO, and then in solution we have what? We have CO2 plus aqueous. And then we can also see that we have the silver, which is Ag, and that we also have what? Ag plus aqueous. And then of course, we can see what? We can see the Soul bridge and the voltmeter there. Okay, 6.1 says that we need to define the term what? The term anode. Okay, so with the definition again, we know that we need to do what? We need to define according to the examination guidelines. So it says here the electrode, so the definition for the anode, the keyword, remember, when it comes to the exam, then we are going to be dealing with what? We are going to be dealing with the keywords. So it says the anode, the keyword here is what? Is the word electrode. So it says the electrode where what? Where oxidation takes place. Okay, so our keyword here will be the electrode where what is happening? Where oxidation is going to take place. So just make sure that when you write your definitions that you use the correct what? The correct keywords there. Then 6.2 says write down the oxidation half reaction for this cell. Okay, so it means that for you to be able to write down the oxidation half reaction, it means that you must first identify what is it that you have in between the two half cells. And if you are not able to choose the correct elements or ions that you have inside the half cell and on the electrode, it therefore means that even when you write your half reaction might also be wrong. But what is it that you are going to look at? You are going to look at what? You will see that on the electrode you have a CO. And then inside the solution, what is it that you have? You have a CO2 plus. So that means that you are going to go to your table and look for what? And look for a cobalt that has a CO and a cobalt that has what? That has a CO2 plus. So in case if there's another one, then obviously it means that you need to double check that you use the correct one. And the correct one will be the cobalt that has what? The cobalt that has a CO and the cobalt that has a CO2 plus there on your table 4B. And then from there, what is it that you are looking for? You can see that in terms of the other electrode, you have a silver there. And then when it comes to this electrode, you have an Ag plus aqueous. So that means that you are going to go to your table again, and then you're going to look for what? You are going to look for that silver that has Ag and what? An Ag plus. Once you find them, because it says write down the oxidation half reaction, then you are going to compare the two to say which one, because if you need to write the oxidation half reaction, it means that you need a reaction that will be undergoing what? Oxidation. But if you are going to be using table 4B, then how are you going to determine which one is undergoing oxidation? It means that you are going to be using the letters what? ABC. When you use the letters ABC, you will see that the one that is at the top, if we are using table 4B, is going to represent what? Is going to represent the anode. And then from there, we said that the B, it represents the Soul bridge. That will help us when we are writing the what? When we are writing the cell notation. And therefore, whatever that is at the bottom, it represents the what? The cathode. So if you go and look at your table 4B, you will see that it is arranged in the following. Meaning the cobalt is where? The cobalt is at the top and then the silver is at the bottom. So if that's the case, it therefore means that the cobalt will undergo what? Oxidation. And then the silver, it therefore means that it's going to undergo what? Reduction. So once you are then able to differentiate to say, okay, if this one is undergoing what? Oxidation, and this one is undergoing what? reduction, then you can come back and answer this question here. Write down the what? The oxidation half reaction. So now from here, it means that you must be able to know how to write down that oxidation half reaction. How are you going to write it? Now we have identified that the one that will undergo oxidation is what? Is the cobalt. So therefore, how do we write it? When you write the oxidation half reaction, you are writing it from where? You are going to write it from the right to the left. And when you write it from the right to the left, what is it that you are going to have? You are firstly going to have the CO, which is this one there, the CO, and then after you've written the CO, the arrow that you are going to have, where must it face? The arrow must face everything that you have on the left. And for that to happen now, we can then turn the arrow to the right-hand side. And if it's facing everything that you have on the right-hand side, it therefore means that on the right-hand side, then you are going to have what? CO2 plus, which is there on your table 4b, CO2 plus by what? Plus by the 2 electrons. So from here, because they just said write down the oxidation half reaction, what is it that you are going to do? It therefore means that you are not going to be changing anything from here. So basically, you are writing it as it is from the table, but what is it that you are doing? You are writing it from the right to the left. So that is your oxidation half reaction. So when it comes to questions like this, you need to make sure that you collect all the marks there. Okay, the next one says that you need to write down a balanced net cell reaction. So for you to be able to write down a balanced net cell reaction, what is it that you are going to need? It therefore means that you are going to need the oxidation half reaction as well as the reduction half reaction. So from the oxidation half reaction, what is it that we have? Remember we said that the oxidation half reaction, we are going to write it from the right to the left. And then very important, so on the table, it's going to appear with what? It's going to appear with the 2 arrows there. So you need to make sure that once you have now decided that this is my oxidation half reaction, what is it that you are going to use? You are going to use a single arrow. As well as for the reduction half reaction, it's going to be from the left to the right. Now, once we have decided that this is my reduction half reaction, what is it that you are going to do? Again, it means that you need to use a single arrow. So now that is very, very important. We are not going to be using double arrows because the double arrows would mean that the reaction can undergo what? Oxidation, or it can undergo what? Reduction. So now let's start by writing the what? Let's start by writing the oxidation half reaction. Okay, so it means that we are going to have what? We are going to have the CO because we are going to write it from the right to the left. So it's CO to give us what? To give us CO2 plus by what? Plus by the 2 electrons there. Okay. And then, so I'm writing it as it is, CO to give us CO2 plus by 2 electrons. Next, we need to write down the what? We need to write down the reduction half reaction. With the reduction half reaction, what are we saying? We copy and paste. So when we copy and paste, it means that we write it from the left to the right, but then instead of a double arrow, we use what? A single arrow. So when we copy and paste, we are going to have what? We are going to have Ag plus by what? Plus by the plus by 1 electron, and to give us what? To give us Ag. So it means that we are rewriting this. It's Ag plus by 1 electron to give us Ag there. So from there, so the first step when it comes to balancing, or when it comes to a balanced net cell reaction, the first step is what? Writing the correct half reaction in terms of what? Oxidation. Have we done that? Yes. Number 2, you need to write the correct half reaction in terms of what? Reduction. Have we done that? Yes. Then number 3, what is it that you are going to check? You are going to check the electrons to say, are the electrons balanced? So now you will see that by the cobalt, how many electrons do you have? The cobalt, we have 2 electrons. And then by the silver, how many electrons do we have? We have 1 electron. So if that's the case, it therefore means that we need to do what? We need to balance the number of electrons. So if we are balancing the number of electrons, then what are we going to do there? So with the silver, it means that we need to multiply by what? We need to multiply by 2. Why are we multiplying it by 2? So that we can have the same number of electrons on the cobalt as well as the same number of electrons were on the silver. So now if that's the case, then what are we going to have? We're going to have 2Ag plus by what? So the 2, because we're multiplying the 2 inside of the brackets. So we multiply the 2, and when we multiply the 2, it's going to become what? A big 2 multiplied by what? Multiply by 2 electrons, because we are multiplying these 2 inside of the brackets. From there, what is it that we are going to have as a product? We are going to have 2 what? 2Ag when we multiply this 2 again into the brackets. So from there, we will see that we have what? The number of electrons are balanced. How are they balanced? We can see that here for the cobalt, we have 2 electrons, as well as for the silver, we have 2 electrons. Now that the number of electrons are balanced, then we can write the what? We can write the balanced net cell what? Reaction. When we do that, what are we going to have? So if now we have balanced the silver half reaction, it means that we're no longer going to be focusing on which one? On this one, on the first one that we wrote here. We are going to focus on the one that has balanced number of electrons. So let's see now, what is it that we have? We have a CO plus by what? A CO plus by, so the CO, so how you write it is that you are going to write whatever that you have on the left-hand side of the arrow. Once you are done, you write whatever that you have where? On the right-hand side of the arrow. So what is it that we have currently? When it comes to the oxidation half reaction, we have the cobalt. So we write the cobalt. Plus by what? Plus by 2 what? Ag what? Ag plus there. Okay, and that is what we have on the left-hand side. And then on the right-hand side, what is it that we have? So we are left with CO2 plus. So we write that CO2 plus, that is what we have left there. Plus by, what else do we have? We have plus by 2Ag. So can you now see the importance of why you need to be able to write that? The half reactions in terms of what? The correct half reaction in terms of oxidation and the correct half reaction in terms of reduction. Because once you are not able to write the correct half reactions, it therefore means that even the balancing will also be what? Even the balancing will also not be correct there. So that is how we do our net cell reaction. Then the next one says, write down the cell notation for this galvanic cell. So for you to be able to write down the cell notation, very important again, you need to be able to write down the half reaction in terms of oxidation and the half reaction in terms of reduction. So once you're able to write the half reaction there, so again, we have already written that to say our half reaction is what? Is this one here for the cobalt, and then the half reaction for reduction was this one there for the silver. So once we have now written the half reaction, you will be able to write down the cell notation. And then with the cell notation, remember we said that it is we are going to use what? We are going to use ABC. When we use ABC, we are saying that on the left-hand side, what are we going to have? The anode first. And then we are going to have what? The double line, which means that there's the soul bridge, and then the C there is going to represent the cathode. Okay. So now, when it comes to the anode, what is it that we have? So when it comes to the anode, we have this here. So we have a CO, and then we have a CO2 plus by 2 electrons. So, but this one is a what? This one is a solid, this one is aqueous. Okay, so when we have that, just to show you the phase separators, so it means that we are going to start with what? We are going to start with the anode. So we'll write anode solid. So from the left-hand side to the right-hand side, a cobalt solid, and then we are going to use what? We are going to use a phase separator, which is then one line. Which phases are we separating? We are separating these phases here. We are separating the solid, and then we are also separating the aqueous there. So it will be a solid if ever there is no charge, and then it will be aqueous if ever there's a charge. But of course, you might also have to look at the phases. Sometimes the phases are given. For example, the chlorine will be given as what? The chlorine will be given as a gas. But for some of the elements that you find there, if there's no charge, it's a solid. If there is a charge, then it's going to be what? It's going to be aqueous. For example, on this CO, we can see that there's a charge of what? Of 2 plus there. So if there is the charge, then we are going to say that it's what? It's aqueous. So we start from the left to the right. So from the left, what do we have? CO solid, phase separator. Why phase separator? Because we are saying that we have 2 different phases. One is a solid and the other one is a what? The other one is aqueous. So it's as easy as ABC. So the A is what? The A is the anode. So we've written the anode part. And then the B is the what? The B is the Saw bridge. So the Saw bridge will then be given by what? By the double line there. And then the C is going to represent what? The C is going to represent the cathode. So for the C, this is what we then have. This is what we then have. We have Ag plus, which is aqueous. So you can see that we have a charge. We are saying if we have a charge, then it's aqueous. And then this one, Ag solid. So if there's no charge, then it's a solid there. So from here, again, what are we going to do? The cell notation for both the anode and the cathode, you are going to write it from the left to the right. But you can only write it from the left to the right if your oxidation half reaction and your reduction half reaction are written correctly. So from the left to right, so we have what? We have Ag what? Ag plus aqueous. So we are just rewriting Ag plus aqueous. Then next, what are we going to use? We are going to use a phase separator. Why a phase separator? We've got 2 different phases. One is aqueous, one is what? One is solid. So hence that's why we need to use a phase separator. So that is how you do the cell notation. So again, it consists of what? It consists of the anode, which is the letter A. It consists of the Saw bridge there, which is the double line, and then it consists of the cathode, which is on the right-hand side. Then next here it says 6.5, calculate the what? Calculate the initial EMF of this cell, and that is under standard conditions. So again, for you to be able to do this, you will need to know which one is the anode and which one is the cathode. And then again, we said that for you to do that, you are then going to do your ABC. So you go to your table ABC. The one at the top is your anode, the B is the Saw bridge, and then the C is the cathode. So once you are able to identify, then it means that you can then go on to the table or the formula, and then you substitute there. So when you go into the formula, you will see that you have what? You have E cell is equals to the E cathode minus the E anode. So you need to make sure that you write the correct formula, since you will have a formula sheet in the examination. So make sure that you write the correct formula. The formula says what? It says E cathode minus E anode. The formula does not say what? It does not say E cat, okay? E cat or En. So you need to make sure that you do not cut the formulas. With the formulas, you copy and paste. So you write exactly what is there on the formula sheet, okay? So what is there? It's what? It's the E cell is equals to the E cathode minus the E anode. So once you've now done that, it means again, you would know which one is representing your what? Which one is representing your cathode, which one is representing your anode. Then you're going to go on your table. So we have already said that the silver is the what? Is the cathode, and then the cobalt is the anode. So you're going to substitute those values. This is the value for the silver. The silver is the cathode. So the cathode is 0.8 minus, so of course the minus is from the formula. So you continue and rewrite the minus there. Minus what? Minus the anode. So you'll see that the anode has what? If the anode has a negative value, or even if it was the cathode having a positive or a negative value, then you rewrite it exactly as it is. You are not going to remove the negative value. You rewrite the value as it is. So from there, it will be the E cathode plus bi, because negative and negative, they'll give you what? They'll give you a positive. So from there, finally, you are then going to write your what? You are then going to write your formula. And then with your formula, you just need to make sure that you, if ever there's any rounding off, you remember you always need to make sure that, especially towards or at the end of the answer, you round off your answer to 2 decimal places. And then again, for you to get that mark, make sure that you write the correct what? The correct unit, which is V or volts there. Okay, next one here, we have the electrolytic cell. So it says the apparatus below is used to demonstrate the electrolysis of a copper 2 chloride solution. Both electrodes are made of what? Both electrodes are made of graphite. Very important, okay? So we have some important information here. So it says the electrolysis of a what? Of a copper 2 chloride solution. So when they talk about that, then we know that what are they talking about? So the copper 2 chloride solution, it means that they are talking about the electrolyte. So very important, the electrolyte is copper 2 chloride. Then next, what is it that we can see? It says both electrodes. So it means that you must know what is an electrode, okay? So both electrodes, meaning where we have the anode and where we have the cathode. Both of them, it says they are made up of what? Made up of graphite. So now it means that, again, if you don't know what is graphite, then for some of the questions, it means that you will not be able to answer. So you must just make sure that you familiarize yourself with the word graphite. The word graphite is carbon. So carbon, that is the very same carbon that you find there on the periodic table. So that carbon has the letter what? It has a symbol C. So both electrodes are made up of carbon, okay? And then the first one, this is define the term what? Define the term electrolysis, okay? So again, with definitions, we're going to define according to the examination guidelines. So it says here, the chemical process in which what? In which electrical energy is converted to what? Is converted to chemical energy there. Next, 7.2, it says which component in the diagram indicates that this is an electrolytic cell, okay? So firstly, you must be able to differentiate between a galvanic cell and an electrolytic cell. So we know that if we now see a galvanic cell, it will be when the 2 electrodes are in 2 different half cells, or in 2 different beakers. But then when we have an electrolytic cell, it is when the 2 electrodes are immersed in what? In 1 beaker there. Okay. So next, what is it that you are going to see? You will see that a galvanic cell has what? It has a Saw bridge. But how do we then identify what? How do we then identify the electrolytic cell? So with the electrolytic cell, you will see that we have what there? You will see that we have a cell. So that will be the component that indicates that this is what? This is an electrolytic cell. 7.3, it says, is electrode B the anode or the cathode? Write down only anode or cathode. Remember, we said that you need to know the polarity for both the galvanic cell as well as the electrolytic cell. So with that, again, you can then have a way of remembering. So we can then use this again on APS, okay? So that will then mean that the G is what? The G is the galvanic cell. The anode is what? The anode is negative. And then with this one, then we are saying that the anode is what? Is positive when it comes to the electrolytic cell. So with this, again, we can say games are nice on apes, and that is just to help you to remember. Then again, if this is the case, if now our focus is on the electrolytic cell to say the A is the anode and the P is positive. So the anode is positive where? On an electrolytic cell. It means that when you look at the electrolytic cell, then you must then be able to identify now which one is the positive one or which one is the negative electrode. So this will then go back to your what? Go back to your electric circuits where you then talk about the what? The cell or the battery. So you will see that you have a longer line and a shorter line. The longer line is the what? Is the positive terminal of the cell, and the shorter one is the negative terminal of the cell or of the battery then. So if that is the case, then if that is the case, and we are saying that the anode is what? So we are saying the anode is positive. So if the anode is positive in an electrolytic cell, it means that electrode A must be the what? Electrode A must be the anode. If electrode A is the anode because the anode is positive in the electrolytic cell, it therefore means that this one, which is B, must be representing the what? Must be representing the cathode here. Okay. So 7.3 says, is electrode B the anode or the cathode? Write down only anode or cathode. So therefore it means that our answer for electrode B will be what? It will be the cathode. 7.4 says, give a reason for the answer to question 7.3. So what will then be your reason there? We just said that this is because it is what? It is negative then. So it says the electrode is what? The electrode is negatively charged. And where do we see that? We are going to see that information where? From the cell. So it therefore means that if you do not understand, or if you do not know how to use the cell to identify which one is positive and which one is negative, it means that you will not be able to answer your 7.3 and your 7.4. So just make sure that you know that the longer line is the positive terminal of the cell, the shorter line is the negative terminal of the cell. And then if that's the case, it means the positive side is the anode and the negative side is the cathode. And then again, you are going to use the very same, this one, the GAN, G-A-N, to say the galvanic is the, in a galvanic cell, the anode is what? Is negative. So you can use the very same to answer questions on the galvanic cell. Then 7.5 says we must write down the name or the formula of the what? The name or the formula of the reducing agent there. Okay. So with the reducing agent, remember the reducing agent will be a substance that is undergoing what? A substance that is undergoing oxidation. So if that's the case, it means that you must first be able to identify which one will be undergoing what? Which one will be undergoing oxidation, and how are you going to do that? Remember, number one, we said that we are going to break down the electrolyte. So very important, when it comes to an electrolytic cell, you need to make sure that you master or you know how to break down the electrolyte. But before you even know how to break down the electrolyte, you must familiarize yourself with what? With the names of the electrolytes. Because now if they give you a name, how are you then going to, how do you then translate it into symbols, okay? So we can see that when it comes to the electrolyte, we have what? We have copper 2 chloride. So if we have copper 2 chloride, it means that this is the copper, Cu2 plus and what? And Cl minus. So we are given a compound which is then combined in this way, CuCl2. So if you are given CuCl2 and you break it down, you will see that the copper, you will have what? Cu2 plus, and the chlorine, because chlorine we find it where we find it on group number 7 on the periodic table. So therefore the chlorine will have what? Will have a charge of -1. And then where do we find the copper? The copper, we find it on the transition metals. So number one, if you have a compound like this, you need to be able to break down the electrolyte. Okay, so in case if you are now asking yourself how we got the 2 there, when you cross multiply the charges, the 2 will go down there, and then the 1 of the chlorine will go down to the copper. So number 1, you need to break down the electrolytes. When you break down the electrolyte, you will see that if it's copper 2 chloride, when you break it down, it's going to become Cu2 plus and what? And Cl minus. So if you have broken down the electrolyte, it means that in solution here, what is it that you are going to have? You are going to have a lot of Cu2 plus minus and a lot of Cl minus in solution. Then you have now identified which one is positive and which one is what? Is negative. Then number 2, what is it that is going to happen there? It means that the chlorine, which is negative, is going to migrate to the what? So the N ions are going to be migrating to the anode there. And then the cation ions, so the cation ions are positive. Cu2 plus is positive, it's going to be migrating to the cathode. So the cathode is negatively charged. So the Cu2 plus will be migrating to the cathode. And then the Cl minus is going to be migrating to the anode. Okay? So number 1, we break down the electrolytes. Number 2, migration of the ions. Which ions? The cation ions and the N ions. Which cations and the N ions? They are coming from the electrolytes. So currently we have 2. We have Cu2 plus and Cl minus. Cu2 plus is what? Is a cation, and then Cl minus is what? Is an N ion. So N ions are migrating to the anode, and then the cation ions, Cu2 plus is migrating to the cathode, right? And then from there, we need to take into consideration the types of electrodes that we have. So you will see that we have what? We initially they told us that we have graphite, and then we said that graphite is what? Graphite is graphite is representing carbon. So from there, if the chlorine is migrating to the what? If the chlorine is migrating to the anode, it therefore means that the chlorine will undergo what? The chlorine will undergo oxidation. Okay, and then if the Cu2 plus is migrating to the cathode, it therefore means that the copper will undergo what? Reduction. But then again, this will depend on what? This will depend on the electrodes that are given. If, for example, now you were given copper as electrodes, so if the anode and the cathode were given as copper, then it will therefore mean that you are going to then apply what? A different rule. But for now, we are just going to focus on what we have, which is what? Which is the carbon and the carbon there. Okay. So with the carbon and the carbon, we are saying that the chlorine will undergo what? Will undergo oxidation. Why? Because it's migrating to the anode. And then the copper is going to undergo what? Reduction. Why is it going to undergo reduction? Because it's migrating to the cathode. Once we have now established that the chlorine is going to undergo what? The chlorine is going to undergo oxidation. Then you need to go to your table. When you go to your table, what is it that you are going to say? You are going to rewrite, you need to rewrite the oxidation half reaction of what? Of chlorine. Why? Because chlorine is migrating to the anode, and if chlorine is migrating to the anode, we know that the anode that is where what? That is where oxidation is going to take place. So now when we write the oxidation half reaction, this is what we are going to have. We are going to have 2Cl minus. Why? Because we write it from the right to the left. 2Cl minus to give us what? To give us Cl2 gas. So we are just rewriting whatever that we have there. Plus by what? Plus by the 2 electrons there. Okay, so if now we have this, we then need to identify what? We then need to identify the reducing agent. So how do we identify the reducing agent? A reducing agent is a substance that undergoes what? Oxidation. If it's a substance that undergoes oxidation, it means that we are going to write the oxidation half reaction. Once we have then written the oxidation half reaction, the reducing agent will be the reactant. What is the reactant? It will be whatever substance that we have there on the left-hand side of the arrow. So reducing agents are reactants only if your oxidation half reaction is written what? Correctly. Okay. So it therefore means that if reducing agents are reactants, then the reducing agent in this case will be our what? It will be our chlorine. Okay. So now we need to be careful. The question says write down the what? Write down the name or the formula. So because they gave you both options, it means that you could have written, so Cl minus is the formula. So if you wrote the Cl minus, it was going to be correct. Or if you wrote the what? If you wrote the name, which is the chloride ions, that is also going to be correct there. Okay. The next it says what will be observed at electrode B when the cell is what? When the cell is in operation. Okay. So we've already said that this is where we are going to have what? This is where we are going to have the anode, and then this side is where we are going to have the cathode. And then when we spoke about migration, we said the Cu2 plus will migrate there, and then the Cl minus will migrate there. Okay, so when it comes to what is then going to happen, then you need to write your observation. So if then we need to talk about the observation, by electrode B, if we know that that is where we have the cathode, then it means that when it comes to the half reaction, then you can look at your table 4B and look for what? And look for Cu2 plus and Cu. So this is the half reaction that we will have in terms of what? In terms of reduction there. Okay. So if this is then the half reaction, it says what will be observed. We can see that according to the half reaction, we have Cu2 plus. Where is it going? It's going from the solution to the what? It's going from the solution to the electrode. So when the Cu2 plus is going from the solution to this electrode, what is it that we are going to observe? There's going to be what? There's going to be a mass increase. Or we are also going to observe what? A reddish brown substance is going to form there. 7.7, it says write down the half reaction that takes place at electrode B to justify your answer. So again, with the half reaction, remember, where is it going to come from? We said because Cu2 plus is migrating to the cathode, it means that we are going to write the half reaction in terms of what? Of reduction. So you will see that on your table 4B, you are then going to get it in this way, having what? Having the two arrows there. So the half reaction, it means that you now need to write the what? You now need to write the reduction half reaction. How do we write the reduction half reaction? We are going to copy and paste. Then when you copy and paste, you will then have the following, right? You will have your Cu2 plus. So from the left to the right, Cu2 plus by 2 electrons to give us what? To give us Cu there. And then remember, you are going to use what? You are going to use a single arrow. Okay. The next one then says, write down, okay, so 7.8, write down the name or the formula of the product that is formed where? The product that is formed at electrode A. So with the product then, how are we then going to identify what is the product? We already said that the chlorine is migrating where? The chlorine is going to migrate to the electrode A, which is the anode. So in order for you to be able to answer this question, it therefore means that you must be able to write the what? You must be able to write the half reaction in terms of oxidation. Because why oxidation? Because we know that at electrode A, that is where we have oxidation taking place. So when you write your half reaction, you are going to use the chlorine, and then the half reaction will be written from where? From the right to the left, because that is our oxidation. So we will have 2Cl minus to give us what? Cl2 gas plus by 2 electrons. So when they say the product, if they talk about the product, then we know that they are talking about whatever that we have where? On the right-hand side. So on the right-hand side, you will see that we only have two things. We have 2 electrons and the what? And the chlorine gas. So therefore, our product will therefore be what? The chlorine gas or Cl2. But they said write down the name. So again, we need to be careful there. So if they say the name, then you have an option of writing chlorine gas, or if they say the formula, you also have an option of writing what? Your Cl2 there. Okay. Next, we have electronic properties of matter. Now again, learners, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. So if you have any questions, learners, you can send your questions to the following WhatsApp number, 079-578-2908. Okay. So with this one then, we need to know, we need to define semiconductor, intrinsic semiconductor, as well as doping. Number 2, when it comes to this topic, you must be able to identify what? Be able to identify semiconductors, be able to identify intrinsic semiconductors. Number 3, know the elements that can be used for doping. Group number 3 and group number 5. Number 4, you should be able to discuss what? The N-type and the P-type semiconductor, the construction and the working of a p-n junction, and then you should know the characteristics of the p-n junction diode. And then, of course, all of these are according to the examination guidelines. And we are saying that if you know all of that, you should at least be able to get a minimum of that 6 marks there. Okay. So now we have a question 4 here, and it says, semiconductors are materials that are very important in the electronic industry. Give 2 examples of intrinsic semiconductors. So it means that for you then to be able to answer these questions, you must know which ones are the intrinsic semiconductors. So remember, if you look at your periodic table, it starts on the left-hand side there with the hydrogen, and then we have group number 2, then we have transition metals. So after the transition metals, you will see that we have group number 13, which is the same as your group number 3, and then group number 14, which is the same as group number 4, and 15, which is the same as group number what? Group number 5 there. So if it says give 2 examples of intrinsic semiconductors, then we know that we are dealing with what? We are going to be dealing with group number 4 there. So from there, it means that if they now just say give 2 examples, it means that you are then able to write the what? You are able to write the name. So where the name is going to come from, intrinsic semiconductors are found on group number 4. So the first one there, you can write the symbol or the name. The first one is silicon, which is Si. The second one is what? Ge or germanium. And then we can also have what? We can also have carbon, which is the letter C. And then we can also have tin or gray tin there, which is Sn. So again, it means that for you to answer this, then it means you must understand what are intrinsic semiconductors and where do we find them on the periodic table. So if you can then just master that, we find them on group number 4, even if they say you must give 4 of them or 3 of them, then you will be able to identify them using the periodic table there. 4.1.2 says, write down the scientific term for the process in which impurities are added to what? Are added to intrinsic semiconductors. So again, this goes back to what? Knowing the definition or understanding the definitions. And how will you understand them? You will then have to use the examination guidelines. So the scientific term will therefore be called what? Doping there. Okay. The next one, it says, consider the diagram below representing a p-n junction diode connected to a source of voltage. Okay. So then it says, is this diode above a forward or a reverse bias? And then you must be able to give a reason for your answer. Okay. So it means that for you now to be able to answer this question, then you should then identify what is it that you have on the diagram. So we can see that we have a p-type material and what? An n-type material. So just to remind you on this one, we previously said that the triangle will be what? Will be pointing. So if it's pointing, because the triangle there is sharp and it's pointing, Therefore, it represents the p-type material. And then this one, the line is not pointing. So because it's not pointing, it will represent the n-type material. So this one that is pointing, because it's a triangle, it's going to represent the p-type material. So now you need to identify the two to say, okay, what is it that you have? So you have a p-type and an n-type material. And then you will also see that you have what? You have a shorter line and a longer line. So what is the connection now? The longer line, we said, is the positive terminal, and the shorter line, we said, is the negative terminal of the cell. Then what is it that you are going to look at? You are going to look at the connections. You will see that when it comes to the connections, the n-type is connected to the what? The n-type is connected to the positive terminal of the cell. And then what is happening? The p-type is connected to the negative terminal of the cell. So if you have such a connection, it therefore means that you have what? You have a reverse biased. Okay. So it says here reverse biased. Why? Because the p-type material, this one here, is connected to the what? To the negative terminal of the cell, and the n-type material is connected to what? To the positive terminal of the cell. So if you had a forward bias, then what were you going to have? The n-type material would be connected to the negative terminal of the cell, and the p-type material would be connected to the positive terminal of the cell. So just make sure that you know the difference between a forward bias and a reverse bias. With the reverse bias, we are saying it's n-type, which is connected to the n-type is connected to the what? To the positive. Okay, so these two, and then we are saying that the p-type is connected to the negative terminal. But with a forward bias now, what are we saying? We are saying it's the p-type connected to the positive terminal and the n-type connected to the negative terminal of the cell. So that is how you would then answer this type of a question there. Okay, so again, this chapter, we then find it where? We find it on our paper 2, as well as the chapter on electrochemistry there. So just to remind you again, the p-type, we can also call it the anode. So in case if you then have to label, and then the n-type, which is the one that is not pointing. So the p-type, or the p-type, which is what? Which is pointing, we call it the anode. And then the n-type, which is not pointing because it's a line, we call it what? We call it the cathode. So just make sure that when you go for the examinations, you are able to remind yourself of that diagram there. Then next, when it comes to now your paper 1, you need to make sure that you know the definitions and that you refer to your examination guidelines when you're writing those definitions, okay? Then it says all long questions will require you to remember a definition or two. These are easy marks, okay? So make sure that you know your definitions, because for almost every question that you will find there, especially on paper 1, there is going to be a definition. And then the importance of the data sheet and how it relates with definitions and theories, laws or principles. Then again, you know that you can have your routine calculations, which are normally 3 marks. So with that, make sure that with the formula, you copy and paste. So you are not going to cut the formula, maybe for convenience. You write it as it is. And remember, you're not going to manipulate the formula. So if they give you R is equals to V over I on the formula sheet, you will write exactly that. And then number 2, we're going to do what? We need to have the correct what? Substitution. With the correct substitution, you need to make sure that you know how to do what? You know how to do your conversions. Remember, paper 1, the majority of paper 1, you will be converting. So just make sure that you know how to convert. And then the last one, you need to have what? You need to have a correct answer. But remember, that correct answer, it needs to go with what? It needs to go with the correct unit. So let's say you now write your correct answer, but there is no unit, then you cannot expect what? You cannot expect a mark there. So for every answer that you give, it needs to have a unit, but make sure that you have what? You have the correct unit. So for you then to know the correct units, it means that you must be able to do what? You practice enough. So it needs to have a correct unit as well as what? As well as the direction there, okay? So if the direction is to the left or the direction is to the right, then you write that. And then which ones are going to have directions? That will be our vectors. Why vectors? Remember, a vector is a physical quantity which has what? Magnitude and direction. But if we have scalars, a scalar is a physical quantity which has what? Magnitude only. What is magnitude? It's the size. But then again, if it's a scalar, if they say calculate the magnitude, it means that you need to calculate the size. If you are calculating the size, it therefore means that you need to give the correct unit as well, but then you're not going to give out the what? You're not going to give out the direction because it's a scalar. Then when it comes to the formula, if you are asked a question and you have to write a formula, but then you do not substitute, then you are not going to get a mark. So make sure that if you write the formula, then with the formula, you must have what? You must have a substitution. That is when you will then be getting a mark for the what? For the formula. But if you write a formula and then you leave it as it is without any substitution, then you are not going to get any marks for that formula that you have written there. Then when it comes to mathematical skills, it says the use of mathematical formula that is provided in the data sheet. Okay, so be able to use the data sheet, and then scientific notation. In your paper 1, on some of the questions, you are required to give your answer in what? In scientific notation there. Okay, and then with the scientific notation again, just make sure that at the end, you round off your answer to what? To 2 decimal places. And then conversion of units, that is very important. Make sure you know how to convert. Then we have vectors. Remember, we said if we have a vector, then we're going to give direction. But if it's a scalar, then there's no direction. Then again, make sure that you are able to interpret the graphs. Remember, with the graphs, we said that if you divide the y-axis, so with the graphs, remember, we said that if you divide the y-axis with the x-axis, then what is it that you are calculating? You are calculating the gradient. But we said that if you then multiply the y-axis and the x-axis, what is it that you are calculating? You are calculating the area. So just make sure that you familiarize yourself with calculating the gradient between the 2 points. Okay. Now we have capacitors and capacitance. Again, very important. You need to make sure that you are able to define the following capacitors as well as the capacitance. And then again, remember, we are saying that you are going to be defining according to the examination guidelines. Okay, with the definition again, we are saying that we are expecting the 2 marks for each definition. Okay, and then next we can have what? We can have formula and substitution. So you need to make sure that you familiarize yourself with the formulas that we have when it comes to capacitors and capacitance. So we have those 2 formulas there. So you will get a mark. Remember, if you write the formula, you are able to substitute as well as with the correct what? With the correct answer there that has a correct SI unit and that has the correct SI unit there. Okay, so we are saying that with the formula and the substitution, even without the answer, we're expecting about 2 marks there. And then again, we need to know the factors that are affecting the capacitance. If you know a minimum of 2 there, then we're expecting about 2 marks there. And then again, you should know what examples of capacitors used in technology. So overall, then we are saying that you can then have a minimum of what? A minimum of 7 marks, and then the other marks will then be added onto that there. Okay, so familiarize yourself with the formula sheet and what formulas do you need to use when it comes to this chapter here. So now let's have a look at this question here. It says in a motor starter, parallel plate capacitor consists of what? Two identical aluminum plates, each with an area of what? Of 4 times 10 to the power of negative 4 meters squared. The plates are separated, so we are given area, and then remember to do what? Remember to highlight for yourself as well when you get to the examination so that you are able to see the information that we have there. So the plates are separated by a distance of what? Of 0.06 meters. And then it says with what? With air occupying the space between the plates there. Okay, 6.1.1, it says we need to define what? Capacitance there. So our definition there is the what? The amount of charge that is stored per volt. Remember here, we said we are going to define according to the examination guidelines. 6.1.2, calculate the capacitance of the parallel plates. So with this one, where you're going to go? You're going to go to your formula sheet there, and then you're going to choose the correct formula according to the information that you have. So you will see that with the information that we have what? We have the area as well as the distance. So it means that we are going to use a formula that has those two there. So then you will see that because it says calculate the capacitance, so C will be the capacitance, and then E naught will be the constant. Where you're going to get the E naught, you will get it there on your data sheet. So because it's a constant, then what is it that you are going to do? You are going to copy and paste there. And then A is given by the what? A is given by the area. And then we have what? We have D, which is the what? Which is the distance there. Okay, so from there we are going to write we're going to write our answer with the correct formula there. So just make sure that when it comes to this chapter, you check carefully as to what is it that you are given there, what units are you given there. So for this question now, we can see that we are given what? We are given meters and meters squared. So therefore, we do not need to convert. But then if you needed to convert, you just need to make sure that you check so that whenever you substitute correctly there, or you substitute values that are converted correctly there. Okay. So the next one there says that 6.1.3, it says state two factors that affect the what? That affect the capacitance of a capacitor. Okay. So it says state two factors. So it therefore means that it's going to be what? 2 factors for 2 marks. So therefore 1 mark for each there. So this is then what we have. We have the total surface area of the plates. So you will see that when it comes to the area of this one as opposed to the area of this one has what? This one has a bigger area or a bigger plate area. So if it has a bigger plate area, then what is it that we'll have? We'll have more capacitance. Okay. But then you're not expected to then explain further on those questions because they're just saying that you need to state the 2 factors. So when it comes to the total surface area, we are saying that a bigger one will have what? Will have more capacitance. And then number 2, it says the distance between the 2 plates. So we see that this one has a smaller distance as compared to this one there. So the bigger the distance, then we know that the less the capacitance. Okay, so it means that we've got the area there and the distance. And then number 3, it says the type of dielectric material. So the material that will be in between here. So if we have air as compared to us having what? As compared to us having mica, it says that the mica now as compared to air is going to have what? Is going to have more capacitance. So again, the question said that you needed to give 2 there. So if you gave 2 there, then that was going to be good enough there for the question there. Then next we have our electric circuits. So with electric circuits, you're expected to know the following definitions: current, terminal potential difference, the EMF, the resistance, Ohm's law, power, and the internal resistance. And of course, these definitions are there according to the examination guidelines. Then number 2, you know that with your electric circuits, we are expected to do what? We're expected to do calculations. So you can do calculations maybe based on your series circuit or your parallel circuit there, or the combination of the two. Number 3, it says give the difference between what? Ohmic and non-ohmic conductors. So you will know that an ohmic conductor, it does what? It obeys Ohm's law, and a non-ohmic conductor does not obey Ohm's law. Then you must then be able to know the graphs to say, okay, an ohmic conductor will be a straight line graph, and then a non-ohmic conductor will not be a straight line graph there. Okay, so again, with the ohmic conductor and that graph, you must just make sure that you are able to calculate the what? You are able to calculate the gradient there, because we know that for this one, the gradient is therefore given by what is given by the resistance. Because for the graph, what is it that you are going to have? You will have the potential difference as well as the current. So remember, we said that if you are looking for the gradient of the graph, it's going to be what? The y-axis, which is change in V, divided by the x-axis, which is change in I. So when you have change in V divided by change in I, it's going to give you what? It's going to give you the gradient. The gradient is therefore given by the what? By the resistance. So when the question comes in the examination, they're therefore not going to say calculate the gradient. Rather, the question can then come and say calculate the resistance there. So if they say calculate the resistance, then you know that what is it that you need to calculate? You will have to go to the graph and calculate the gradient. So the gradient will be given by the gradient, which is M, will be given by change in V divided by change in I. So from there, what is it that you are going to do? You know that for you to calculate the gradient, it will be V2 minus V1, and then I2 minus I1. So you will then go to the graph, choose 2 points, you calculate the gradient gives you the resistance. So just make sure that you are able to use the graph to calculate the gradient, and with the gradient, you will then get the resistance, okay? Then we can have another graph where we have what? Where we have the I and the V there. And yes, it will then be a straight line there. So again, for this one, the gradient, so for this one, the gradient is given by R. So for this one, what is it that we have? We have the gradient is given by change in I divided by change in V. So if this is the case, and according to Ohm's law, we have V over I, and according to this graph, we have I over V. It therefore means that for this graph, what is it that we are going to have? The gradient will therefore be equal to 1 over R instead of the R that we have on this one. So 1 over R will be equal to change in I divided by change in V there. So then on this graph, if they now say calculate the resistance, what is it that you are going to do? You are going to calculate the gradient. Once you then get your answer of the gradient, so let's say your answer for the gradient, 1 over R, let's say your answer for the gradient is what? Is 2. What is it that you are going to do? You are going to cross multiply. So when you cross multiply, you will have what? You will have 2R is equals to 1. Then you can then divide on both sides by the 2 so that your R can be 0.5 ohms. So just make sure that you are able to use the graphs to calculate the resistance on both graphs there. Then, yeah, we are saying that we will have what? Formula and substitution. So just make sure that you familiarize yourself with the formulas that we have there in your electric circuits, and that you are able to substitute and get your answer there. Then number 3, okay, so then it says here factors that affect the resistance of a substance. So just make sure that you know those factors for the examination there, okay? Then we have what? We have series and parallel circuits. So we know that when it comes to a series circuit, what is happening in terms of the current? The current will be the same. So if the current is going to be flowing in this direction there, so if this is our cell, the current will be flowing from, according to conventional current, from the positive terminal to the negative terminal. So if that's the case, then we are saying that the current will be the same at all the points. So if we measure the current at this point or at this point or at this point, the current is the same. But we are saying that when it comes to a series circuit, the voltage is what? The voltage is divided. And then for you to be able to calculate the resistance, you can use the formula R total is equals to R1 plus R2 plus R3. Then we have the parallel circuit. With the parallel circuit, this is what we are saying. We are saying that if we are to measure the voltage here and the voltage there and the voltage on this resistor, we are saying that the voltage is the same. Again, what is it that we have? We have conventional current. It's going to flow from the positive terminal to the negative terminal. So with the parallel circuit, we know that the current will be split. So some of them will go to R1, some of the current will go to R2, and some of the current will go to R3. So if the current is divided, it therefore means that to get the I total is going to be I1 plus I2 plus I3 from the three different resistors. Then you need to make sure that you know how to use the formula. So with the formula for parallel, it will be 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3. So again, we can use the following to say SAPD is what? SAPD is paid. So with that, what are we saying? The S, it's representing what? The series circuit, this one. So the series circuit A is what? Is the series R. So the A is R. P is what? Is potential. So potential, we are talking about the voltage, are potential dividers. So SAPD, we are saying that series are potential dividers. We can see that with the series circuit, the potential difference is divided. So if you know that with the series circuit, the potential difference is divided, it means that the other one must be the same. So we are saying if the potential difference is divided, the current is what? The current is the same. Now going to the parallel circuit. P is what? P is the parallel circuit, or in a parallel circuit, or parallel circuits are, they are what? They are current dividers, okay? So we can see that the current is what? The current is divided. So parallel circuits are current dividers. So if the current is divided, it means that the other one must be the same. Current is divided, therefore the voltage is what? The voltage is the same. So you can then use that to help you remember them. So now going to this question here, it says the circuit below consists of what? It consists of a 6 ohm and a 5 ohm resistor connected in parallel, and then unknown resistor R in series as shown below. And then it says that the switch is what? The switch is closed there. Okay, then it says the total power dissipated in the parallel part of the circuit is what? Is 50 watts. So we are given the information. Then it says the voltmeter reading across resistor R is what? Is the 8 volts there. 6.2.1 says that we need to define the term what? The term power. Again, we are going to define according to the examination guideline. So it says it's the work done per unit time. Then 6.2.2, it says you need to calculate the effective resistance of the parallel combination of the resistors. So with this one, when they say effective resistance, they are just saying that you need to calculate the what? The total resistance. So the word effective, it simply means that you calculate the total resistance in the parallel combination. So just make sure that you know how to calculate the total resistance. Then what formula are you going to use? Then you know that because it's parallel, It's either you can have 1 over Rp or 1 over Rt is equals to, then you can have 1 over R1 plus by 1 over R2 there. So from there, you can then substitute according to the resistors that you have there. Okay. So it means that on this one, then we should have what? We should have a 4 here. We should have a 4 as well as a 12 ohm there. Okay. So the effective resistance, then what is it that we have? Then you go onto your circuit there, and then you then need to identify which resistors then are connected in what? In parallel. So how are you going to see that? It means that you need to go and look at your battery. Remember, the longer line represents the positive terminal and the shorter line represents the negative terminal. So we are going to use what? Conventional current. Very important. So how does conventional current flow? Conventional current, we know that it flows from the positive terminal to the negative terminal. We are saying which one is positive, the longer line, which one is negative, the shorter line. So from there, you can draw your current to say, my current is going to flow in this way. But you can see that when the current gets to this point, the current will be split. So when the current is split, then you know that that is where you have your parallel connection. So it means that this resistor 4 ohm and the 12 ohm are connected in what? In parallel. But now let's see what happens to the current after the two resistors. So now the current will then continue. So it will get to this point, and then it will get to this point until we have the what? Until we have the total current coming from the 4 ohm and the 12 ohm coming together there to give us the total current. So when it then goes out there, it will then go until it gets to the resistor R, which is therefore unknown there. Then when it gets to this one, we can see that this one, because the current is not split anywhere after it has left 4 ohm and the 12 ohm, it therefore means resistor R is connected in what? Is connected in series. So where is our focus when we calculate? Our focus will be on the 4 ohm as well as on the 12 ohm. So you write your formula 1 over Rp. What is Rp? The P is the total what? Is the total resistance in what? In parallel. So P for parallel is equals to 1 over R1 plus by 1 over R2. So you then substitute, you will have 1 over 12 plus by what? Plus by 1 over 4. But you will see that with your answer, you will then have 1 over Rp. So if you then put that in your calculator, you will then have a fraction there. So when you have a fraction, you just need to make sure that you cross multiply. And then when you cross multiply, you will see that for your final answer, you are going to have what? You are going to have the 3 ohm there. So with this one, you must just make sure that you familiarize with yourself with the word what? Effective resistance. When they say effective resistance, they're saying you must calculate the total resistance. In this case, we're in the parallel combination. Then it says the total power dissipated. So we have the total power that is dissipated where? In the parallel part of the circuit. So now we know the parallel part of the circuit is which one? Is this one there. So we know the power. Power is what? Is the letter P, and the total power is 50 watts. So now you can then circle there which part is the parallel combination, is the 4 ohm and the 12 ohm, and that is where we have the power. What else do we have? From the previous question, what did we calculate? We calculated Rp, which is the total resistance in the parallel part of the circuit. Then it says the voltmeter across the resistor R. So the voltmeter, this one here, across resistor R, what is it reading? It's reading 8 volts. And then what is it that we need to calculate? We need to calculate the resistance of what? The resistance of resistor R. So if we need to calculate the resistance of resistor R, if we go straight to Ohm's law, this is what we're going to have, okay? So then with Ohm's law, then we will see that we have what? With Ohm's law, we will see that we have the resistance is what? The resistance is unknown. Okay, do we have the potential difference? Yes. We have the potential difference because we can see that the connection here on resistor R is what is 8 volts. Do we have the current? No. So are we then able to continue? Not at the moment. So that means that if we are to solve this question, then we will need the what? We will need the current. Okay. So now this is how we are going to solve it. We can see that we can use the formula what? P is equals to I squared multiplied by what? Multiplied by R. But what is it that we have there? We can see that we have the power. So we have the power, but this power is mainly on what? This power is mainly on the parallel part of the circuit. Then we also have the total resistance, but we're on the parallel part of the circuit. So if we have the power and the resistance in parallel, then we can be able to calculate the what? The current. Then when we get this current, what does it mean? It means that that is the total current that we have on the total current that we have where the total current that we have in terms of the circuit here. Okay. So if we have the total current, remember we said that the current when it comes to the 4 ohm and the 12 ohm is split, but the current will then come together there. So as it comes together there, if we are to put an ammeter to measure the current, we are saying that at this point, we are going to be measuring a total current of what? Of 4,08. And this current will then travel where? It will then travel to resistor R. Now that we have the current using Ohm's law, then what are we going to do? R is equals to what? R is equals to V over I. So let us check down. What is it that we have? We have we were given V, which is what? Which is the 8 volts. And then we were also given the what? We were also given we calculated the current, and we got the current as 4,08 there. So from there, we have substituted the potential difference. We have substituted the current. We can now have the resistance there, which is R. Okay, so it therefore means that currently, what is it that we have in terms of the resistance? It means that this resistance or the total resistance that we have, when it comes to the parallel part, we said we have the 3 ohm, and then the current that we have on this resistor is what? Is 2,01. So the combination of the two will give us a total resistance of what? Of 5,01 ohm. Okay. Then it says resistor R is removed and replaced with an ammeter. Okay. So learners, I'm going to ask that we take learners a 1 minute break. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. So if you have any questions there, learners, you can send your questions to the following WhatsApp number, 079-578-2908. Now, it says here resistor R. So which one are we looking at? We're looking at this one here. This resistor there. Resistor R is removed, and what is it replaced with? It's replaced with an ammeter. Okay, so we no longer have a resistor there. If we no longer have a resistor and we have an ammeter, it means that number one, what is it that you think will happen? Because the total resistance here For the 4 ohm and the 12 ohm, the total was what? The total was 3 ohm. And this resistor was providing a resistance of what? Of 2,01 there, okay? So if we had 3 plus by 2, and now we are saying that we are removing this resistor so that we can have what? An ammeter. What is going to happen? Initially, if we are to calculate the total resistance of the circuit, it would be R total is equals to R in the parallel plus by R in the series. So the R for the parallel is 3. The R for the series was 2,01. So therefore the total is what? Is 5,01 ohm. So if we are removing this one, the resistor, and we are replacing it with an ammeter, what is going to happen? It therefore means that the total resistance of the circuit will now decrease. Why will it decrease? Because it means that we will no longer have this 2,01. We will only have the what? The 3 ohm. So that is our number 1. So it says, how will this, so if we remove resistor R, how will this change affect the what? The current that is going to go through the 12 ohm resistor. Choose from increase, decrease, or remain the same, and then you must explain your answer. So we now have what? We are then going to explain this according to Ohm's law. Okay, so it says that the current is going to increase. Why is the current going to increase? It says because the total resistance of the circuit is going to decrease. So we said that what is happening? The total resistance of the what? The total resistance of the circuit is going to decrease. Why? Because we no longer have the 2,01, we only have the 3. So if the total resistance decreases, it therefore means that the current will increase, because the resistance and the current are what? They're inversely proportional. If one decreases, the other one will increase. So hence we are saying that the current will increase because the total resistance of the circuit decreases then. Then the next one now says switch S is now open, okay? So where is the switch? This is now the switch here. So again, it means that you must be able to identify the what? The switch is there. So now currently, as we see it, what is happening? It is closed. But now what are they saying? They're saying that now it is what? It is open. So if it is open, it means that we can then have something like that there. So it says what is given to the name, or what is given to the reading on V1 when the switch is what? When the switch is open. So we should know that the name that will be given will be the EMF. That is the voltage that we are going to be reading. The voltage that we are going to be reading when the switch is open, and that voltage is what? Is the EMF. So it means that with this one, you must understand the EMF as well as the definition. So if you were then not able to understand the definition, it means that you will not be able to answer this question here. Okay, so the next one that we have there is our electromagnetism. So with this one, you need to make sure that you know the definitions: electromagnetic induction, your magnetic flux, Faraday's law, Lenz's law, transformers, generators, as well as the motors. Then with that, you need to know the right-hand rule, left-hand rule. Very important, the energy conversions between what? Between the generators and the motors. Then you need to know the principles as well. Know the principles in terms of the generators, the principles in terms of the motors, how a generator works and a motor works, how the current is induced, and the functions of the components. Okay, again, you need to know what examples of generators, motors, and what? And transformers. And then, again, according to the examination guideline, you need to know the graphs of voltage versus time and the current versus time. That is for an AC circuit. And then again, of course, it means that you need to know the formulas that you need to use in terms of the electromagnetism, and we have those 3 formulas there. Now the difference between generators and motors, we know that generators are going to convert what? Mechanical energy to electrical energy, and motors are going to convert what? Electrical energy to mechanical energy. And then, very important, if they ask you what is the principle that generators work on, then the principle will therefore be what? Electromagnetic induction. What is the principle that motors work on? Motors work on the principle of motor effect. Then generators, what do? They produce current. What about motors? They use the current. Now, when it comes to the direction, for generators, we are going to use what? The right-hand rule. And for motors, very important, the left-hand rule. So when we talk about directions and the left and the right hand, what are we saying? If they say generator, when you determine the direction now of the current or the magnetic field lines, you specifically use your right hand to do that. If they say motors, then you specifically use your what? You specifically use your left hand to determine the direction. Principles, we said generators, it's your electromagnetic principle. For a DC and an AC, they're using what? They're both using electromagnetic induction, but the energy conversion for DC and AC, they are using the very same what? Energy conversion. Then know the difference between a DC and an AC. DC, very important. What does it have? It has a commutator. But the commutator, you need to write what? You need to write a split ring commutator. Okay, and what? And the brushes. But with generators, you need to make sure that you write what? It has slip rings. So very important, know or write the correct spelling. AC generator is a what? Slip ring. But with a DC generator, you need to write it out in full. It's going to be a split ring what? Commutator. Then the uses for generators. We have electroplating with metals, electrolysis for the manufacture of chlorine, and so on there. Then again, the uses again for an AC generator, it's electricity generation at power stations, generators at amusement parks, hospitals, and other essential services. Okay, so learners, I'm going to ask that we now take a 3 minutes break, learners. 3 minutes break there. Okay, learners, so we have now run out of time, and this is then the end of our lesson. And I would like to leave you with the words of Nelson Mandela that says, "It is in your hands to create a better world for all who live in it." With that said, learners, I would like to sign out. Miss T. Thank you.